Good evening, everyone, and a very warm welcome to this evening's webinar. My name is Tom McDermott, and I'm the chair of the Project Managers Society. We are delighted to co-host this event, Baldrumman Above Ground Installation, Enhancing Resilience and Flexibility of the Gas Network with the Institute of Gas Engineers and Managers, IGEM. And a special thank you goes out to Conor O'Reilly there, the chair of IGEM, and for his support. We've had a lot of interest in this evening's presentation, actually with 143 people signing up. So I'm not sure what number we're at now, but a very strong number of people interest. So that's great. It would be good to know at this point. It would be good to know where people are joining us from. So while you're waiting, please enter your name, organisation, and where you are located in the country or outside the country, just in the chat box section, please. Questions for the presenters, they'll be pitched at the end and can be raised throughout the presentation, but please enter them into the Q&A section only. And again, provide your name and your organisation along with your query, and we'll get it raised if we can at the end. So a little bit about the PM Society. We currently have 6 committee members from various engineering disciplines. We're always interested in meeting and getting in new members to support the Society. Engineers Ireland welcomes new members, and details for joining can be found on the website, or anyone in Engineers Ireland would be delighted to answer any questions you may have. If you are a member of Engineers Ireland and would like to receive notifications on the PM events, just click on the box from the PMS on your membership page. Presentations are held on a monthly basis. Details are available on the events page of the website. Events are made up of breakfast events, evening events like this, and in non-COVID times, which we're in now, we would include site visits. Our next event, actually, we haven't got it scheduled fully yet, but it is on stakeholder engagement, and that'll be supported by Irish Water. We're hoping to have that by, hopefully that'll take place by the end of the month. So please watch out for that one. We welcome your feedback on events, and any suggested topics for future event is always helpful. So don't be afraid to enter that into the chat box, and we'll pick that up within the Society. So moving on to today's event. Firstly, I would like to thank Declan Burke, Ciarán Butler, Kevin Buckley, and Stephen McNamee for preparing for today's presentation, but also supporting the PM Society and IGEM. Declan Burke is a design delivery manager in Gas Networks Ireland, with responsibility for design and transmission and distribution, gas network, leading designs to achieve a net zero carbon network. Declan is a chartered engineer, a fellow of IGEM, with over 20 years experience in the gas industry. Declan has held a number of positions within the organisation. Currently chairs the Engineer and CPD Committee for Gas Networks Ireland, is an industry expert, and represents Gas Networks Ireland at technical committees at national and European level. Ciarán Butler is a technical director at RPS. He is a chartered engineer and is experienced in delivery of infrastructure projects from feasibility and planning stages through to preliminary detailed design and construction stages. Ciarán has been involved in a variety of technical and project management roles on a wide range of projects, including gas pipelines and installations, waste management, carbon capture and storage, and renewable energy. He has over 20 years experience in the gas industry and currently leads RPS gas team. So Stephen McNamee is a senior project manager for Murphy Ireland, with responsibility for all gas transmission connections. Stephen has over 20 years experience in the design, build and civil engineering and gas transmission projects in Ireland and the UK. He successfully managed and delivered many of the Gas Network Ireland transmission projects in recent years, including the Ballylough AGI bypass. And finally, Kevin Buckley is the Energy Project Director for Murphy Ireland, with responsibility for delivering projects in the transmission and gas and power network. Kevin graduated from UCC Civil, Structural and Environmental Engineering in 2002 and joined Murphy's Graduate Engineering Programme. Kevin is a Fellow of Engineers Ireland and is passionate about his development of engineers. He chairs the CPD committee, as well as leading the Graduate Engineering and chartership programs for Murphy. So I've seen some of the slides and I'm really looking forward to this presentation. It's very, very interesting. Now I'd like to hand over to Declan Burke, who will introduce the presentation in a little bit more detail. Declan, over to you, please.
Yeah, thanks very much, Tom. Evening, everyone. I'm delighted to be here this evening there to share this presentation, and in collaboration with RPS, our designers, and Murphy's, the contractors. And just to say thanks to Engineers Ireland, in particular, Chair Tom McDermott, and Conor O'Reilly, the chair of IGEM, the Irish section, and Sinead and Engineers Ireland for facilitating the presentation this evening. So thanks very much. So look, again, so I have a number of slides here, and I'll just time check myself there. And look, this AGI, it's an exciting project from Gas Networks Ireland's perspective, Baldrumman AGI, and in terms of enhancing resilience and flexibility of the gas network. And just I have about 10 slides, and I suppose, like, before I get into my set of slides, just in terms of an overview there. So I'm going to cover the presentation just in terms of the client perspective and G&I, or Gas Networks Ireland, and I suppose internal speak, you'll hear me referring to G&I, that's how we abbreviate. And then RPS, our designers for the project, will give Ciarán Butler will give an overview in terms of the designer perspective, and Kevin Buckley in Murphy's, just in terms of the contractor perspective. And look, G&I, we have in-house design teams ourselves who worked on this project, but we also supplement with engineering service providers, and we have a number of them. In this instance, it was RPS on this project. And so just moving on. Like, so look, this project, look, I hope you find it interesting. Look, it's a significant project, unique project on the gas network, significant scale. It's, I suppose, Baldrumman AGI, it's about a 3-acre site. Look, from our perspective, like, obviously, it goes without saying, safety paramount. And obviously, people might have an interest in, as we talk through this project, just in terms of how we manage logistics, project controls, the overall program itself, and quality. There are some of the things that we pick up on, and I suppose additionally, like, in terms of the uniqueness of the project, in terms of facilitating future works on the network. So look, that's what I'll go through. So just a small bit about Gas Networks Ireland. Look, I'm sure, or hope people know of us. I know there's a wide variety of people on the call, just seeing the names pop into the chat in different countries. So who we are, look, we're Gas Networks Ireland. We're the transmission system operator and a distribution system operator in the Republic of Ireland. We have assets in Northern Ireland and assets in Scotland. I suppose our purpose is, look, in terms of keeping Ireland's energy moving. Our vision is to be at the heart of Ireland's energy future. And look, it's exciting times in terms of the gas industry, in terms of the whole biomethane, the hydrogen agenda, decarbonisation, to achieve net zero. Look, we have assets of 16,000 or just under 15,000 kilometres between high pressure and medium pressure, which I call 4-bar gas pipelines, over 710,000 customers, and a 2.7 billion renewable ready asset in terms of pipelines, above ground infrastructure. And we already have biomethane on the network, and we have a number of CNG, compressed natural gas, both private and public, in forecourts. We are working away in terms of hydrogen, and we have an innovation centre around hydrogen in Dublin, in around Brown's Barn. And look, the gas network, look, in terms of it's there, like, it's, I suppose, demonstrated down through the years, its resilience, and it's there to support renewables and the dispatch of renewables. So that's it. So just in terms of overview of the project. So here, and I'll use the mouse there, obviously the map of Ireland. Here we have two subsea interconnectors coming into Dublin. This is the area of focus for this evening's presentation. The red lines are high pressure pipelines across the country. Predominantly the subseas are up to 140 bar, and the onshore is between 85 and 70 bar, depending what type of assets that we're looking at. So here, as I zoom in here, like I suppose, like we have existing gas coming in here to Block AGI. This is from our subsea pipeline stroke onshore from Loch Shinny. And I suppose the project scope was in relation to around de-risking a section of the network in around Block AGI, where a number of pipelines converge. So these are all the red pipelines here that converge in this central area. You have pipelines heading west and south and north, and here you just have the N1 to the left hand side. So just in terms of a schematic, so look, we have interconnector 1 coming in from Scotland, and IC2 here that we refer to. One is 750, one is 900 millimeter diameters. One can transport up to 60%, the other up to 30, but the flows are interchangeable in terms of splitting flow through the network. It comes into Block AGI, and then it heads south to gas to Cork and Dublin in terms of 750 and 450 pipelines, onwards through a 750 pipeline to Galway, Limerick and around the country, and then heading up towards Drogheda, which we call the Northeast Pipeline, and Cavan, etc. So I suppose for ourselves, like in terms of de-risking, this is we have a number of pipelines that are coming centrally, and we were looking to de-risk that part of the network and I suppose enhance network flexibility. So part of that involved relocating 3 above ground pig traps, pipeline inspection gauges here, where these are facilitated to launch and receive pipeline inspection gauges for pipelines, internal inspections. So part of that, this project was relocating some of that infrastructure so there'd be less assets above ground, and likewise de-risking this part of the network where IC2 would come into a different part of the network called Baldrumman. So look, we'll talk about this in a bit more detail in terms of RPS and the designers. So the AGI in question is, I suppose the focus is Baldrumman AGI, just north of Balloch, around 1.5 kilometres. And this pipeline here is actually as built, a bit of 750 pipeline that comes into the AGI, the above ground installation, and it crosses the M1, which we'll talk about, or which I suppose our designers and contractors will talk about in a bit more detail. And so another schematic on this. So this is what we were looking to achieve in terms of the outcome, in terms of the project scope. So as I said earlier, you have gas coming in here, interconnector 1, and you had the 6 pipelines converging here. By building this Baldrumman AGI, you de-risk Balloch AGI in terms of IC2 gas now comes in here into the north of Baldrumman AGI and can head west through pipeline to the west through 750 millimeter pipeline. And also this project enables future network flexibility in terms of this pipeline network would operate at 85 bar. So you'd have gas coming in from the interconnectors in along where this mouse is here, and reduced from 140 or 125 bar to 85 bar into Baldrumman, and then in turn again a phase 2 of the project which we're working on, where the gas would be reduced again further from 85 to 70 bar and flow back out here and into Balloch, and then could flow onwards to Cork, Dublin, or around the network. So this configuration from a transporter perspective, I suppose, one, it de-risks the existing block installation, but it gives a lot of flexibility in terms of a network operator, in terms of manipulating the flows across the network, in terms of increasing flexibility, whereas before gas would have came in here to Balloch and just headed south and west. Now it can still come in from IC1, in from IC2 into this new AGI, and the flows can go west to Galway, Limerick, head down and back up the Cork Dublin pipeline. So a lot of flexibility from a transporter perspective. So that was a key part of the scope in terms of enabling that piece of infrastructure. In addition, the flexibility and resilience in terms of enhancing network capability. I suppose this is Baldrumman AGI, another project that's ongoing here in the southern area reinforcement. So what it means is the network as it stands in terms of all these blue lines here is the transmission network that I said operates up to 70 bar. Part of this project, the Baldrumman AGI, will enable the network to be split and GNI to operate a two-tier pressure network. So what we'll be doing is post-completion, obviously this project is completed, our next phase, we'll be putting in pressure reduction here in Baldrumman to go from 85 to 70, and from 85 to 70 here at Goat Island, and we'll be able to operate this part of the network to 85 bar. Now these pipelines are all designed for 85 bar. It's newer part of the network. This section of pipeline dates back to the 80s, and this was designed with an MOP of 70 bar. So obviously we can't operate that. So we can operate this, but this gives a lot of flexibility in terms of gas entering and exiting the network, in terms of flexibility, in terms of manipulating the flows across the network, in terms of either through pressure control or flow control. So just in terms of I suppose the timeline around the project. So look, it kicked off in 2017, mid-2017, and about 4 years for this project. It was commissioned in 2021, November 2021. A significant project by any degree, a 3-acre site, and Ciarán will talk about that just in terms of site selection. Like in terms of like what was required for the site, obviously we needed planning permission. Look, which a lot of the activities would have happened during this cycle between 2018 and 19 to get it ready for construction in 2020 in circa June. So in terms of the type of consents, we would have needed planning permission from Fingal County Council during this timeline. We would need section 39 in terms of, there was just under 800 meters of new pipeline required. So we needed approval from the commissioner regulators of utilities. We would have needed our own financial approvals from the ministerial approvals from TII in terms of crossing the M1 motorway. There was a significant amount of material, and just, I suppose, the whole logistics around materials, and materials would have been long lead items, would have been ordered at the prelim design phase back in 2018. In between 2018 2019, you're into the detailed design phase. With prelim design can take up to 6 months, then you're into 9 months then for detailed design, and G&I were subject to the utilities directive and the whole material procurement. And you're looking at 12 months, and for some of these long lead items in terms of 900 millimeter diameter valves. And likewise, just in terms of the pipeline manufacturer in Germany, T's, etc., putting in place a construction contract. So a lot to achieve during this design phase before you can move into construction, which commenced in June 2020. Then you're into the commissioning phase, and the project was commissioned in November 2021, and quite an aggressive timeline, albeit it's over 4 years. But if you take between the approvals, the materials that needed to be ordered, and then during this phase, post completion of the project, there would have been a project closeout and lessons learned. But during that whole process, we would have a system in place where we do HAZCONs, site inspections, corrective action procedures, things that might feed back from the field in terms of either designs or design deviations or updating to our standard drawings, where we need to take back for future projects that may be ongoing in parallel in terms of other network activities. So just in terms of, from a client perspective, again, around risk management, so just to touch on some of these. So obviously this project, based on the timelines, it was during COVID. Like, so again, there was a lot of challenges, and I suppose Ciarán and Kevin in particular probably speak to that. We had a crisis management team in place in terms of meeting every week across things in GNI, not just in particular to this project, but look around limiting face-to-face meetings, separate canteens, separate offices, etc. Gate approvals. We have a 5-stage gate process in gas networks, and gate 1 is concept, gate 2 is design and materials procurement, and gate 3 is award of construction contracts. And really that's around financial controls in terms of the monies on the project. So each gate, each time you move through the gates, the projects are reviewed. Is things going on plan? How's the estimate doing against controls? There's monthly runoff in terms of costs, also in terms of approvals. Like, so at gate 2, we'd be looking for monies to order materials, etc. We wouldn't go back past gate 3 till we have all our approvals in place, till we have firm dates around materials, till where we are in terms of awarding the construction contract, etc. And that's a significant budget then in terms of awarding contracts and gate 3 approvals. Then we have a gate 4 process in terms of around our lessons learned, and did we how were we in terms of budget against outturns actuals, and then a gate 5, which is like, did we do what we say we do? Did the project set out what it sought to achieve? Obviously, materials was a big ticket item on this project in terms of risk. Like, there was teas coming from Germany, pipes from Germany, bends, valves from Italy. So a lot of logistics, and we do have an internal team around logistics management, etc., and third-party inspections. So a big ticket item. So between the whole designing of materials, material inquiries, the procurement process, till you did take up to 12 months before you actually issue a purchase order to a supplier, and then you're up to 9 to 12 months then waiting on materials. So all that logistics around that, and obviously vendors don't start till they have a purchase order, like, you know, so quite challenging in terms of materials and logistics. Obviously, way leaves, 2 private landowners involved. Obviously, we have our own statutory powers around compulsory purchase orders, but again, we have a track record in terms of achieving mutual consent from landowners, something like 99%, and working closely with the Irish Farmers Association, etc. Live gas tie-ins. So again, I touched on safety. We had 9 live gas tie-in connections on the project, and for that we needed to develop a sequence document in terms of telling the Murphys how they would do the hot taps, which one to do first, etc. Like, you know, so that was again working closely with the designers, RPS and Murphys, and ourselves, our ops team, and developing our own sequence of live tie-ins. We had non-routine operations, NRO, for all these tie-ins, and then for any venting of gas and etc. in terms of emissions reductions, looking to do a lot of that at our existing block AGI to minimize any venting. And then network activity, and I suppose what I mean by that, network activity, obviously this is a significant project happening on the network. There would have been other projects happening, not to this scale, but we may be upgrading other above ground installations. We may be connecting new customers. We may be doing some refurbishment. Again, we have a number of resources in terms of operational personnel that need to be on site and be present, certainly around hot works. And again, it was around looking at risk on the network. Okay, we're doing Baldrumman AGI, working with our network analysis team and planning that sequence of activities, our grid control, the timing of these works, what else is happening, and then minimizing that in terms of the level of activity, to just in terms of managing risk across the network. So look, in terms of sustainability, again, look, a significant project in terms of biodiversity. GNI, we support the All Ireland Pollination Plan. We conduct a lot of ecology surveys. We've published a number of sustainability reports. For this project here, Baldrumman AGI, it's a 3-acre site. You can see the mouse here, and this coloured map to the right-hand side, this is the outline of it here, and you can see it going around. So there's 2 phases where we purchased 14 acres. I suppose you might say, why did we purchase such a significant land holding? Well, the 2 landowners involved were either side of the motorway, and I suppose purchasing land this side would have meant it would have been more difficult for the landowner to access and become landlocked. So we enhanced the biodiversity strategy around that site in terms of planting 13,000 trees. Now, we don't have 13,000 trees planted at this moment. It's 2 phases. I suppose we were required to acquire a forestry license above 1,300 trees. We developed a number of ponds and meadows, etc., and walkways across the site, and significant in terms of the scale of biodiversity. We're committed to it, and we have a lot of our projects now feature in terms of biodiversity, and it's dealt with during the design process. So just moving on, just conscious of time. So just in terms of the stakeholders, so there's, I suppose, 25 plus stakeholders, and a lot more involved depending on where you are in the process, through design, through commissioning, through construction. Suppliers in Europe, Germany, in the UK, the whole logistics around managing all the various suppliers and at what point in the process. But internally, we do have stakeholder teams and communications teams. We develop a stakeholder management plan. It's a live document as part of the project plan. It's updated on a regular basis. We have meet with the comms team regular for these projects and other projects, given the scale of them. And again, the whole communication with the local authorities, letter to residents around the significant works that are taking place. So really, just the stakeholders and the communications is obviously key to any project like these. And obviously understanding the timelines with other statutory bodies and all connections, be it a connection from ESB networks or a connection from AIR, and how all those facilitate, or how they're all sequenced in terms of the process, the materials delivery, in order all things can be ready within reason in terms of the contractor, etc. So that's my presentation concluded, and I'm going to stop screen sharing now, and I'm going to hand over to Ciarán Butler there in terms of RPS.
Thanks. Hi, everybody. I'm Ciarán Butler. I'm working with RPS. I'll take you through some of the design aspects of the project. I might just expand a little on some of what Declan has gone through, and I think further on, Kevin's going to expand further again. You'll see some of our design, how it's come to life at the construction stage. Very briefly, let's go on to the first slide here. RPS, just a quick word about RPS. We're an integrated multidisciplinary consultancy firm. Some of you would know us, but just in case you don't, or you mightn't even realize, we're operating in 6 continents, 125 countries, but maybe more importantly, we've over 700 specialists in Ireland, over 5,000 worldwide, and we have a sort of we cover pretty much all the areas of infrastructure, and we've been involved in many projects all over Ireland. And in the case of the gas industry, we've been operating in the gas industry for over 40 years, so we have a strong presence in energy and infrastructure. In terms of our role in this project, we were involved in the preliminary and detailed design, so that involves site selection, the mechanical, civil, structural, and E&I, or electrical and instrumentation design, and also, as Declan says, support the procurement process. We were involved in the statutory approvals, and a big one of those was the planning application, support on the Gas Act application, which is Section 39A, but then there was also a road crossing that Declan mentioned, and that required support there for a Section 53 process under the Roads Act. We did an environmental and ecological appraisal of the project, flood risk assessment, landscape and visual assessment, and we also put together an outline construction environmental management plan, and all of those documents would have fed into the planning applications to explain how our project would have a as low as possible impact on the environment, and was in keeping with proper planning. I might mention just there as well is that as this project, due to its scale and size, it fitted within the normal planning application process with Fingal County Council where it's situated. In other words, it didn't qualify for strategic infrastructure, which is interesting at one level from a planning perspective. We were also involved as a project supervisor for the design process, the PSTP. So part of that involved with our designers working on the design risk assessment for the project. And we're just at the moment now finishing up with compiling the safety file for the project, which is an important deliverable for the end of the project. There is a building element to this. We were the science certifier under the BCAR process, and all during construction, we were responsible for providing design support as things turn up during construction, clarifications, and maybe some on-site design solutions that were needed. We were involved in that with Murphy's and with GNI. In terms of the timeline, Declan's already given a high-level view of the timeline. It's hard to believe we were appointed to this project back in November 2017, so just 5 years ago. The preliminary design would have taken place from that starting point up to about April 2018. And within that process, we looked at design options and we developed a construction sequence. And I'll talk briefly about those as well later. We developed the engineering line diagram and basically a package for review by GNI within their sort of preliminary design process. So it's a stage, I suppose you could say, in the design where once the preliminary design is signed off, that's the starting point then for a detailed design. And our preliminary design was signed off in April 2018. And within that, there would have been a number of items then to follow through the detailed design and HAZOP processes that took place later. In the detailed design, we began using a 3D model, which I'll show briefly as well, which is a helpful part of our design. We developed a detailed layout and a construction sequence document, which was quite detailed and very helpful, which I'll mention later also. The construction tender packages were developed and issued under a fairly tight timeline, as Declan has mentioned there, to get those out by the end of December 2018. And separately then, in parallel, I suppose, planning application was being prepared, and it was submitted in February 2019, and ultimately then it was granted in August that year. So we were very pleased with that. Contractor was appointed in March 2020. That's Murphy's, but COVID was happening at that stage. So as Declan mentioned, construction start didn't happen until a bit later. I think it was June. That's the timeline. Very briefly, our project, if this is a very simplistic slide, it shows a box 100 meters by 100 meters roughly, which is what we assumed for the siting aspect of this project. Phase 1 was the basic AGI, and within that, there's a phase 2 which is the pressure reduction part of this project. It's shown there, if I show very briefly with the arrows here, in between the Gormiston and Balloch AGI part of it. So the pressure reduction would happen between these, whereas, as Declan has explained, the 85 bar network would flow right through the gas station and bypassing Balloch AGI. And that's probably the key point from our perspective on the project, is that it removed Balloch essentially, or decoupled it from the gas pipeline to the west with the de-risking aspect of that and the advantages with it. So that's box of 100 meters by 100 meters is what we need to try and find a location for. So very briefly, I'll talk about the route selection and the AGI site selection. Our study area is in this part, or this rough area here. I'll show you the second gas interconnector is here. Gas pipeline to the west is here, and Balloch AGI is here. And some of the key constraints that we'd be thinking about in this area were existing 110 kV overhead lines, the R132, the M1 motorway, existing NEP or Northeastern pipeline here, which is another 70 bar pipeline. And then there were the 2 Apple Green service stations here, either side of the motorway. So within that area, a sort of a study area or approximate study area sort of emerged. And our challenge was to find a location for a new AGI, a brand new AGI to function as we've outlined, to provide that sort of functionality on the network. And among those key constraints I'll talk about a little bit in the next few slides were the M1 motorway, the 110 kV lines and the flooding. So in terms of constraints, I've mentioned some of the technical constraints, but what's probably very important to mention here as well is the community in the area. One of the key considerations from a community perspective was the potential risk of flooding. That was a very sort of strong point in the area. And also, of course, there will be, and there are existing businesses in that part of the country. Our study area then, in terms of distance, you know, if I go to the next slide, it might be helpful. It just shows a slide to show our AGI and site selection and pipeline route selection process. And we looked at a number of different alternative locations for Baldrumman AGI, looked at 11 sites. And among the considerations there were having to cross existing pipelines, crossing the M1 motorway. We could do it in a number of ways. We could either have one 750 millimeter pipeline crossing the motorway, or if you were to take a site on the western side of the M1, we could have maybe two 900 millimeter pipeline crossings under the motorway. In the end, we selected a site which was to the east of the motorway. It's about 450 meters, I think, from Baldrumman AGI, and that fitted well within our sort of our brief to find a location that was about approximately no further than 1 kilometer from Baldrumman AGI, and to have it at a reasonable distance to gain that de-risking element of the project. In terms of the 110 kV lines, I'll cover that in a slide. We had early liaison with ESB networks. We did some flood modeling, which I'll talk about. And in terms of access, then this is a live gas station. There was an important requirement to have 24 hours a day, 7 days a week, 365 days a year access to the AGI, and we were able to achieve that in the site that we chose via an existing local access road, which was built as part of the motorway. So if I move on from here, the ESB lines there, you can see them there. That's the Glassmore to Stevenstown 110 kV DC lines. The key to I suppose getting that achieved reasonably well, I think, was early engagement with ESB networks. We went to ESB networks when we had a good, clear design layout for the project. We shared that with them. We met them on site. And we were very clear, or they were very clear with their requirements in terms of distance, their way leave. That was all agreed in advance, and as agreed, there was good coordination during the construction stage. So I'm very pleased to say that that aspect of the project, while it was a big constraint, it went very well. In terms of the M1 crossing, that's an image of the M1 crossing close to where the crossing took place. That's from an overpass. It's about 100 meters. Rather, the road itself is probably 45 to 50 meters wide at that location. The crossing length of about just over 100 meters. We did a trenchless construction feasibility study for the crossing, and we looked at different technologies from auger bores and pipe jacks to horizontal directional drilling. Having looked at the SI data for the area, which was available from the M1, and also having some knowledge of the ground conditions from Baldrumman AGI, some of the concerns we'd have had there were groundwater and cobbles or large boulders, which could be quite a difficult challenge for any trenchless construction. We carried out new site investigations then, of course, during 2018 to verify or to substantiate what we thought we knew about that crossing, and engage with TII. And TII's requirement, I suppose the key requirement they had for the project was that the depth of cover would be a minimum of 5.5 meters. So this part of the works was then, it was decided that that would be done by specialists within the contractor's sort of brief. And that's how the construction documents were written. But at that stage, we also had a fairly good package of information for the contractor. If I move on briefly here now, this is just a little bit more detail. It's a development of the earlier slide. You can see the gas lines coming in from Gormiston, leaving via Balloch, and you can see the phase 2 in yellow there. So this layout is essentially what was the basis for our plan that sort of emerged probably around the sort of August stage of our program in 2019. Let me think, the size of the site, we had envisaged 100 meters by 100 meters. In the end, the actual design was about 80 meters by 120 meters. And Declan has mentioned the size in terms of acres. I think a useful benchmark is probably to compare it with the football pitch in Croke Park, which is slightly bigger at 145 by 88 meters. So this is a sort of an important point just to make in terms of its size. The 120 meters means it's quite a long site. And if I then speak briefly about our the flood risk concern that our issue that we had, we addressed that by carrying out a flood risk assessment. That was included with our planning application. So the flooding in the area was modelled using InfraWorks. And this is a picture of what would be before, or the pre-development. It's showing where flood zones would be in terms of depth of flood, and this is the after. So what I'm trying to say here is that after modelling it, we could conclude that there was very little, if not insignificant level of impact on local flooding in the area, and we were able to show that for the 1 in 1,000 year event through modelling. An output of that then, hopefully you can read some of this, was that we concluded that development won't contribute to an increase in the flood risk in the surrounding areas, which, as I said, was an important consideration for the local community. We would limit the surface runoff to 2 litres per second per hectare, and part of that is achieved by the attenuation pond there to the north of the site, which we needed to build into the design. The minimum ground levels then for some of the key buildings on the site were raised in order to allow for potential flooding and extreme events. And then a key aspect of it as well is that the contractor would take measures during construction to ensure that flooding would be managed on site. And I think you might see some of the photographs that Kevin has to show how that was done, and it was done actually very effectively. In terms of the design challenges, then I mentioned the length of the site, and if you can imagine that the site needed to be drained. It was drained to one end. Being a long site, then we needed to be mindful of the falls and gradients within the drainage network. We had the gas pipeline infrastructure within the site to kind of ensure that didn't conflict. We needed to have some cut and fill on the site. And in some cases, that meant that the AGI pipework was quite deep relative to what it would normally be. And for gas pipelines in Ireland, this would be coming in and out of, for example, of this site, the minimum cover would typically be 1.2 meters. So in the case of this AGI, some of the pipes were relatively deep because some of the site needed to be raised. And we were able to model that within our 3D model, which was very helpful. If I move on then, the construction sequence, Declan mentioned this earlier. There's a slide there, or rather an image showing what we would call an engineering line diagram, an ELD. You won't be able to read that, but what's important to say here is that we developed, I suppose, what G&I had already started within our brief. We took that, we developed it a bit further. We produced a series of over 20 drawings to go through each step of the process, including the 9 hot taps that were involved, and we included with that a step-by-step narrative of how each and every valve would have to be opened or closed, as the case may be, and every sequence of the work to make it as clear as possible. That was then reviewed with G&I. We had a very good review process for that, an operations and constructability review meeting, and after that there were several optimizations of it as well. That's the document then that was issued for construction. And during the construction stage, there was even further optimization with input from, I would say, G&I operations and from Murphy's, the contractor. So there was really good collaboration in that sense. And each of those changes, once the design had been there, I suppose it's important to say that there was that design change management took place to record each part of it and to make sure that anything that we changed had followed through, the requisite review process. So we think it was a good example of, developing the process together, and I think that team approach worked very well. In terms of the 3D model, very briefly, we did use a 3D model with Revit and Plant, which is what G&I would use for their projects. We really started that only after the preliminary design was finished, and I think that's probably the right approach. Once we had that layout clear, we were then really got stuck into developing that 3D design. And in doing so, we developed the various parts. As you can see in the bottom image there, it's like, I suppose, a library of different parts, which then, extends G&I's own library of elements. And it then became the 3D model that is a central reference for the project. And within that, then I suppose one thing that I think is important in terms of managing data and the project is that in developing that model, we used standard sizes for various AGI elements, and those elements might be a valve, they might be a T or a bend or whatever. And in making those and putting them into our model, I suppose we learned as we went, but it's important to pass it on, is that as the projects go through the procurement stage, first of all, we have to be very clear about what standard dimensions, ASME or API or other standards, they may be different. Secondly, as vendors produce this equipment, sometimes they will come with a slightly revised design and they ask, can this be used instead? They may add a fitting of a different size, or rather what we call a PUP, which is a short section of pipe welded to the fitting to facilitate construction on site. Those might be a different size. And this is important because as you have the 3D model, and if you think of it as that central reference, we need to be careful about where welds are positioned on the site, and we don't want those positioned over a concrete base or something. So if if you're building a model like this, it's really important that you maintain a very sharp focus on things like that, so that at the construction stage, there aren't any problems. As I say, the material procurement is one example of things might come not exactly as they were assumed, and it's just to keep the eye on the ball, so to speak. That's an image of our 3D model. It's sort of fully developed there in the middle. The top right image is really just a viewpoint of the model as it was rendered and used for the landscape and visual impact assessment. The bottom left, though, is something I suppose is really important to say, as I mentioned, the drainage network and where it potentially conflicted with the buried pipework network within the AGI. So in that model, everything has been modeled, and it was a very useful means of being able to figure out how to fit everything on that site. So that was the upfront design work, and I think it's an example of how doing that bit of design work up front helps to minimize problems at the construction stage. The 3D model then will be updated for the safety file, so that's going to be a reliable source of information for G&I for the next phase of the project, phase 2, as we say. An example maybe of how we use that 3D technology, call it, was in Baldrumman AGI, where we were making other tie-ins as part of the overall project. And when I suppose the areas were exposed to begin tying in, making those hot taps, and an existing bend was discovered which wasn't recorded in as-built drawings. Now, this is something which needed to be, I suppose, discovered at that stage. It's not something that you would do to dig up an AGI, in advance to find something you don't know that's there, if you like. So when it was found, it was very useful to have the 3D model to go and use to find a solution. So what you see there is an image of, we did LiDAR surveys of the tie-in points. We had the various elements of the AGI, which we could then move around on the site, and we needed to do that. And we were able to show that there was a design configuration that could be used on site reliably, which was then proven on the ground with Murphy's. They were able to do that. And I think what's important as well is we were able to capture all of that within that design change process that GNI operates, and document all that clearly for everybody's benefit. In terms of the 3D model, very quickly, you know, we can use that in different ways, and you know, I suppose a key part of it would be to take those mechanical and civil layouts in the detailed design and be able to generate welding isometrics and material takeoffs. And these are the sort of things that you can do very effectively with a 3D model once it's there. But I suppose, as I was sort of mentioning earlier, it's really critical that the information going into that model is reliable and monitored, I suppose, depending if there's any change, to make sure that your model itself then is a reliable central reference point. And then I'll finish on sustainability. It's a key part of, I suppose, what we do. You know, as an organization, we've sort of, we look at projects these days now, and we have a process where we try and sort of document what can we do on this project for our clients that's sustainable, and to add to the project in that way. And this project, you know, we did have a look at that at the very start, and examples of what we did on the project included just, I suppose you could say, the construction sequence is one. Minimized the amount of venting. There was, you know, 3 large pig traps were reused, refurbished and reused. It's fairly important, a big thing. It's, you know, something that GNI was keen to do as well. You know, we limited that surface water runoff. And then the landscaping and biodiversity measures were something that we had hit on at a very early stage, and very pleased to see that that's really been taken up by GNI, and it's something that's I think is going to be a really nice feature of the site. LED lighting, simple things like that, and you know, construction stage. Even at the start of construction, we were able to, you know, accommodate nesting birds, and that was something that I think was a very effective. Construction happened. We had ecologists on the site. We were able to have construction continue, and certain areas were not cleared to facilitate that, which I think was a very good success story. And I think Kevin will talk briefly about some of the water management and bulk fill materials savings that were made on the site also. Again, BIM, as I said, was easy to make. It was easier, I should say, to find design solutions, and that I think has a relevance to sustainability. There are probably more opportunities for phase 2, and some of those are listed there. But maybe to finish from my point of view here, I just think it's worth saying that that whole designing for sustainability is something that's rewarding for people. And I think even though a lot of us are engineers, I think there's a lot of energy that people, you know, we can tap into that and be proud of what we're designing. So at that stage, maybe I can hand over to Kevin.
Hi everyone, I'm Kevin Buckley. I'm the projects director with Murphy Ireland's Energy Division. It's just a slide giving a few details on Murphy's for those of you who might know us. Murphy Ireland is part of the Murphy Group, which is headquartered in London. The company was established in 1951, with the Irish division was set up in 1968. It's 100% family owned, and we've always adopted a self-delivery model. The global revenues are 1.9 billion, with Ireland contributing 217 million of that. We've had 20% growth sustained each year for the last 5 years. In Ireland, we've offices in Newbridge, City West, and Nanger Road in Dublin, and Antrim and Newry in Northern Ireland. The Murphy Group employs over 5,000 people, with 600 of those in Ireland. We've 120 million worth of our own plant and equipment, and we invest fairly heavily in that each year to upgrade and expand the fleet. We operate a 7-sector strategy in Ireland. We work in civils, natural resources, power, water, wastewater, structural steel, piling, and operate and maintain. This is a brief overview of the project. The lads have already been through a fair bit of it. So down here in the bottom right-hand corner is the existing block AGI with the existing pipelines shown in blue. The two interconnector pipelines, one coming in here from the north and interconnector one coming in from the south, and 4 pipelines going out, two to the bottom going towards Dublin, the northeast pipeline, and the gas to the west pipeline. Over here is the tie-in location where we did a hot tap into the live pipeline, the live gas to the west pipeline. And in red is 750 meters of 750 mil diameter steel pipeline. The M1 motorway crossing was here, and Baldrumman AGI shown in orange. And then those 2 connections into the interconnector 2 pipeline. So now that it's all complete, gas from the interconnector 2 pipeline comes in here into the new Baldrumman AGI, where it's diverted either to gas to the west or down to block AGI. And this section of pipeline has been decommissioned. This is an overview of the HSQE stats on the project. So the project commenced in June 2020, which was at the height of the COVID pandemic. There was a lockdown in Ireland and the construction industry was nearly fully shut at the time. The project was deemed critical national infrastructure, so it was let go ahead during the lockdown. It's a credit to everyone on site that they agreed to be tested so often. We carried out over 4,000 antigen tests on the site. We clocked up over 163,000 man hours on the project with a peak of 90 people. There was no lost time incidents or no environmental incidents in the job. There was 414 separate people inducted, which gives an idea of the scale of the challenge. The site is very visible from the motorway, and it was one of the only sites in operation because of the lockdown, so it got an increased attention from the HSA. They visited site twice. Both visits were very positive. Our cultural development program was attended by everyone on site. This is a workshop that focuses on our safety behaviour. Attendees get a deep dive into the Murphy values. Every January, Murphy holds back to work briefings on all our projects. We call that our safe start. The purpose is to refocus everyone following the Christmas break and review and reflect on the previous year's health and safety performance. The one summer and one winter campaigns are held to remind personnel of the seasonal risks associated with the time of year. We also rolled out occupational health screening for everyone on the project as part of our health and wellbeing strategy for the project. So everyone on the project got BMI, cholesterol, blood pressure, and diabetes tested. And there was 2 ISO audits with no observations in either audit. It's a summary of the challenges and successes, or the major challenges and successes in the project. On the right is a picture of the bypass pipeline as it was being constructed. As the first major challenge was COVID-19. As I mentioned, we started during the COVID lockdown. We all had to learn a completely new way of working to make sure we met social distancing requirements. It was particularly difficult at the start of the project to keep PPE and antigens testing in stock. Thankfully, we managed to get through the whole project without any site-based transmission. This thanks to all our employees and G&I buying into the new way of working straight away. Supply chain was the next challenge. Declan mentioned it earlier, that valves and fittings were purchased from the continent. And due to the lockdowns there, some of the key materials were delivered 5 months late. Once G&I became aware of the problem, they asked us to resequence the program to accommodate as best we could. Working together, we were able to ensure that despite all the obstacles, we delivered mechanical completion within the original contract dates. And that leads on to our next major challenge, was winter working. We were required to tie in the new infrastructure into the existing pipeline at 3 different locations. This meant we had to weld onto live 70-bar pipework. Originally, this was scheduled for the summer months during periods of low gas flow. The resequence program now meant that the operation was carried out in the winter months. G&I reduced flow as much as possible to facilitate the works. With early planning, we were able to ensure that we had adequate resources available to complete the hot tap successfully. The fourth challenge was carrying out major works inside and block AGI, which was live. As the lads mentioned, up to 95% of Ireland's gas flows through block. It's imperative, obviously, that the assets remain protected while undertaking large-scale works inside the facility. Lastly, the availability of key resources was a challenge. We were carrying out a major upgrade to one of the compressor stations in Scotland, which is at the other side of the interconnector pipelines at the same time. as this project. So these projects were competing for resources throughout. It's an advantage to Murphy's that we directly employ a lot of the specialist trades required for the project. Like welders, fitters, inspectors, radiographers, pipeline testing technicians, and civil operatives that are used to working in live gas environments. There's significant training required to get ready for the project. Some of the successes then with no lost time incidents in the project. It's testament to our cultural development program. There was no environmental incidents. We worked closely with GNI and RPS at the start to identify any environmentally sensitive areas on site. They were all protected immediately once we mobilized. We achieved the original milestone dates. It was particularly difficult with both COVID and the delay to the materials. The challenges were identified early and we worked together to overcome them. We worked closely with GNI asset inspection team throughout to ensure there was no interruption to the gas supply, and local community initiatives. Then we were highly aware of the impact that any project of this scale can have in a local community. Murphy's and GNI got involved with the local community early on, and some examples were we funded Christmas lights, planting of flowers, and upgrading a local seating area. Here are some of construction stage initiatives that we had. That's a picture of a mobile welding station. Site welding needs a lot of ancillary equipment like power, welding plants, heating equipment, cutting equipment, and alignment tools. We designed and built these units especially for the project that could house everything in one place, and we could safely crane them around the site. Next one is a rotating station. Any welding onto fittings like bins, 90-degree bins or whatever has to be done in a fabrication shop. We'd use rotators where possible to do those welds because it's reduced the number of welders that you need, and it also increased the quality of the weld. Normally the chuck in a rotator will attach to a pipe end, and you'll weld the bend to the other end of the pipe. That means you can usually only weld one side of each bend using rotator, and the other will be manually welded. Due to the large number of welds on heavy wall pipe on this project, our mechanical supervisor designed and built the unit you can see in the picture. So rather than the rotator grabbing the pipe, it's now held onto the bend. This meant that we could get the weld on both sides of the bend. The assembly that you can see in the middle here was able to roll out of the fab shop out into our yard. And this was a significant safety benefit because it allowed us load up the fabrication using a crawler crane out in the yard rather than inside in the fab shop using the forklift. It's always safer to handle stuff using cranes. The last one is coating canopies. See here, the original program we would have carried out site coating in spring and summer. The coating that was required is a multi-component liquid, and it's very susceptible to moisture in the air. It's extremely difficult to apply in winter months. Because of the resequence program, the coating works were forced into more unseasonable months, and to overcome this, we fabricated large insulated canopies. This enabled us to carry on with coating activities using dehumidifiers and heating equipment to get the correct temperatures. It's the hot tap procedure. So we're tying into the live pipelines. All our welders for this would have been specifically qualified for welding live pipelines on this project. That training would have been carried out in Newbridge, and it would have gone on for a number of months before we started. So the first job is to expose the live pipeline. So that's the gas to the west pipeline we can see in the photograph there. Once that's uncovered, the next task was to remove coating to test the tie-in locations. The tests would have included radiography, magnetic particle inspection, dimensional checks, and metal sampling. Then the concrete bases were poured, and the canopy that you can see in the picture was put up just before welding to make sure that conditions were perfect for welding. Once the T's were welded on, they were pneumatically tested, and the sandwich valve fitted onto the top. So each T that you see in the picture there would have taken 3 days welding. You'd have had 4 welders and 2 shifts of 4 welders to do them for 3 days. Once the welding was complete, the next task was to drill into the live pipeline. So the drilling rig was attached onto the sandwich valve. It's here in the photograph. That's a fully enclosed drill that can take the line pressure of the gas. the sandwich valve that we can see the 3D rendering here would have been opened, and then the drilling cutting head could come down and it would cut out this coupon out of the pipe. Once it was drilled, it lifted the coupon back up above the sandwich valve, and the sandwich valve would be shut, and the drill could be taken off. The next operation is to fit on the bypass pipework. This is on the interconnector 2 pipeline. That 18-inch gas pipework was fitted on here. Once that was installed, it was commissioned, and now gas could flow from the interconnector pipeline through half of the new Baldrumman AGI and through the new bypass pipeline onto the gas to the west pipeline. Once that was all commissioned, we could then stop flow in the interconnector pipeline heading for block AGI. That operation was done using a stopper. It's a 3D rendering of a stopper there. The sandwich valve was open and a plug inserted into the pipeline. Once the plug was inserted, that would stop flow coming down along the pipeline here, and the rest of the pipeline could be degassed using vents. That allowed us to do a cold cut to cut out a section of the live pipeline, and we could tie in this section of pipeline into the existing interconnector pipeline. Once all that was done, the bypass was decommissioned and taken off, blanks fitted to all the T's, and the area backfilled. This is the M1 motorway crossing. This was carried out using a tunnel boring machine. Following careful consideration of the site investigation and groundwater, we decided to use an open face TBM. That was down to risk of boulders, as Ciarán said earlier on. Pre and post construction surveys are carried out in the M1 to make sure there was no settlement. We were liaising closely with TII through the whole operation. There was sheet pile pits installed to the north and south of the motorway. And on the southern side for the reception shaft, we installed 4 dewatering wells. That was due to the presence of an artesian aquifer. So we just wanted to relieve groundwater pressure before we started tunneling. The entire tunnel length was 150 meters, and it was 10 days tunneling, 24 hours a day. We decided to go 24 hours a day just to mitigate any risk of settlement on the motorway. Once the tunneling was complete, GRP sliding supports were fitted into the base of the tunnel, and the gas pipe was jacked into position. Each weld was coated with a specialist coating, polypropylene flame applied coating. And once the gas pipe was installed, it was independently tested up to 140 bar before we grouted it in place. Some of the environmental initiatives on the site. We worked closely with GNI and RPS to make sure that there was no excavated material taken off on site. It was all used around the new AGI. Before the project, we invested in eco-friendly welfare accommodation, hybrid excavators, and electric telehandlers specifically for the project. Murphy's are committed to invest in 75 million for 2026 in environmentally conscious plant. The new pipelines were hydrostatically tested to 128 bar. This needed 600,000 litres of clean water. Normally you get that water from potable water pipelines, but with an agreement from GNI in this project, we decided to use water from the dewatering wells in the tunnel following lab tests. This negated the need to import water using road tankers and decrease carbon emissions by 6.7 tonne. We also reused approximately 5,000 tonne of stone that was used to provide access haul roads to the pipeline areas in winter months. The stone was removed, regraded and used to raise parts of the site in the Baldrumman AGI, avoided 250 truck movements. This part of the biodiversity scheme that Declan and Ciarán both mentioned earlier. So the block AGI bypass is part of an ambitious biodiversity scheme by GNI. GNI acquired 14 acres, we can see here in the photograph, of land adjacent to the AGI, in partnership with Murphy's, developed a biodiversity area. The biodiversity area includes 3 ponds, 2 grassland meadows, and over 13,000 native Irish trees. The primary goal is to offset carbon emissions of the facility over its lifetime and enhance biodiversity in the local community. It's great to see a client that are actually willing to spend money in biodiversity rather than just talk about it. The planting will be finished over the next few weeks, and I think it'll really cap off a great project. Thanks very much, and pass it back to Tom for any questions.